Applications of quadratic equations. First number. Suppose a ball is launched straight up from the ground. The height in feet h of the ball after t seconds is in the air is modeled by h of t equals 72t minus 6t squared. Alright, so first, let's get an image of what's going on here. So we have a ball being launched in the air from the ground. Here's my ground. The ball is being launched and reaches my ground again elsewhere. The height in feet is h. My equation is h of t equals 72t minus 6t squared. 72t minus 6t squared. How do I know that this is going to be a parabola or a quadratic? How do I know my graph is going to look like this? What about my equation tells me that? Yeah, so I have this square here tells me I'm going to have a quadratic or a parabola in that form. How do I know that this parabola is going down and not up in this manner? What gives that away?
Because he's throwing it straight up.
Okay, my coefficient here is -6. All right, so if you want to rewrite this, you can write this as -6t squared plus 72t. My leading coefficient is negative, so my parabola is facing down, or called concave down. Part A. How long does it take for the ball to reach its highest point? What is it talking about? Its highest point. Yeah, the highest point on the graph is here. This is my vertex. You can use your graphing calculator, or we're going to do this manually. How do I find the vertex of a parabola? Okay, so we're going to use x equals negative b over 2a to help me find my x coordinate. Or in this case, I'm not going to use x. What can I use since we're talking about h of t? What would it be? T. So t equals negative b over 2a. Okay. What is my b? So I have t equals. My b here is what? Negative. Careful. This should be written as negative 6t squared plus 72t plus 0 in a sense. So my b here is so negative 72 over 2 times a, which is 2 times negative 6. Negative 72 times, negative 72 divided by negative 12, and I get an answer of 6. So 6 what? What does that represent? T is what? 6 what? 6 seconds, okay? So this is my 1, 2, 3, 4, 5, 6. So after 6 seconds, I'm going to reach my maximum height. Is that what it asked for?
No.
Well, how long does it take? So it takes 6 seconds to reach its maximum height. Part B, how high is the ball at its highest point? So now what is it asking for?
Like the height of the ball?
Yeah, so now I'm asking for the y value. So how high is this ball? So what do I do with this? How do I find the height of this ball? Substitute it in, absolutely. So this is the notation I want you guys to use. So I'm substituting in 6 into my function. So h of 6 equals 72 times 6 minus 6 times 6 squared. So h of 6 equals 72 times 6. What is 72 times 6? 70 times 6 is 420. 420 and 12 is 432. Minus 6 times 6 squared. 6 squared is 36. 36 times 6 is 216. Finish it. H of 6 equals 432 minus 216. I should get an answer of 216. 216 what? Units, feet. Very good. Okay. So how high is the ball? Its highest point? 216 feet after 6 seconds. One more question. How long did it take the ball to hit the ground? So I'm just going to take this here for a second. I'm going to minimize this, put this out of the way. So this was all for this part. how long does it take the ball to hit the ground? So what am I asking for? What is it looking for here? Yep. Yeah, it's asking for when does it hit the ground. It hits the ground here and here. What is that in comparison to the graph? This is the x-intercepts. All right, so here's my equation. So I got h of t equals 72t minus 6t squared. If I'm looking for an x-intercept, what must I do? If I'm looking for an x-intercept, what must I do to this equation?
Factor it.
Before we factor it, you can change it to y equals, you can leave it as h of t. The x-intercept means what? What's my y-coordinate going to be?
0.
So my y-coordinate, remember, this is your y. This needs to be 0, so set your y equal to 0. So 0 equals 72t minus 6t squared. Now we've learned a few different ways to factor this. You could do factor, you could use quadratic formula, you could use computing the square, whatever you like. I think here the easiest way would be just to factor out. See what you can factor out. 72t and negative 6t. What can you factor out of both these terms? So take out 6t, leaving me with 12 minus t. I have two factors equal to 0. Set them both equal to 0. 6t equals 0. 12 minus t equals 0. Solve my first one. What do I get here? T equals 0. And t equals positive 12. Okay, so at 0 seconds, the ball is on the ground. And at 12 seconds, the ball is on the ground. So how long did it take the ball to hit the ground? 12 seconds. If you also notice here, where was the highest point? 6 seconds is the highest point here, right? So remember, my graph is symmetric. So if I double 6, what do I get? 12. So that'll be awesome. But for test purposes, quiz purposes, I want to see the notation. Example number 2. Billy owns a house on planet X. One day while he is hiking, he throws a ball into the air, and the height of the ball in meters is modeled by the function h of t equals negative 2t squared plus 10t, where t is time measured in seconds. All right, so we have him on some planet X, throws the ball into the air, follows negative 2t squared plus 10t. This is a quadratic, which is why I have a parabola facing down because
Negative.
my leading coefficient is negative. All right, so here's my parabola. Here we go. So we have h of t equals negative 2t squared plus 10t. First question. What is the maximum height of the ball obtains after Billy throws it into the air? What are we looking for? Maximum height. What are we looking for? Yeah, I'm looking for the vertex again. All right, that's the maximum height. I'm looking for the vertex. Now, of the vertex, this question is asking for the x value or the y value. What are we looking for here? So, what is the maximum height? What part of the vertex do we want?
Y value.
We want the y value. All right, so let's find that y value. How do I get the vertex? Using the formula in the previous problem, so we're going to get t equals negative b over 2 times a. In this case, negative 10 over 2 times negative 2, which is equal to 2.5, or in fraction 9/4. Okay, so 2.5 seconds. So after 2.5 seconds, we'll reach our maximum height. Did that answer the question for part A?
That answers B.
That actually answers B. What does the ball obtain its maximum height? All right, so we got B, so 2.5 seconds. But how do we answer A now? What do we have to do? We have to substitute in, okay? So in this case, we're going to substitute in. So h of 2.5 equals negative 2 times 2.5 squared plus 10 times 2.5. You could just plug this into your calculator, and what do you get as your maximum height after one of you guys have plugged it into your calculator? So negative 2 times 2.5, 20. So we should get a maximum height of 20 feet. Let's just check that again. So negative 2.5 squared. Sorry, 12.5 feet. After 2.5 seconds. When does the ball hit the ground after Billy throws it into the air? So let's get rid of this for a second. Alright, so if we throw this ball into the air, what are we looking for? When it hits the ground, we're looking for meters, sorry, not feet. What are we looking for in part C? The x-intercept, okay? So I want to know when it hits the ground. What do I need to do to my equation in order to find the x-intercept? Set equal to 0, good. So they got negative 2t squared plus 10t equals 0. Again, any means you like to factor this, quadratic formula, factoring, whatever. I think factoring in this case would be nice. What can I factor out of this? 2t or negative 2t. I'm going to take out the negative 2t, leaving me with t squared minus 5. Oops, sorry, not t squared, t minus 5 equals 0. Negative 2t equals 0. T minus 5 equals 0. First case, t equals 0. Second scenario, t equals 5. So at 0 seconds, the ball is going to be on the ground. After 5 seconds, the ball will be on the ground. So when does the ball hit the ground? 5 seconds later.